great big ugly exponent to deal with on the x plus h. Here, the whole process of evaluating the limit is going to be a little bit different because you're dealing with a radical. Go ahead and find out f prime of x on your own. Take a couple minutes to do that. And then we'll talk about using that derivative equation to find out the slope of the tangent line at these different points. All right, so what are we guys getting for f prime of x? Does anybody have an answer? 1 over 2 square root x. Does anybody want to go through getting there? Yes, okay. So we set up f of x plus h minus f of x all over h, and we're taking the limit as h goes to 0. So what does f of x plus h look like? First half of the numerator, what is that going to be? All right, square root of x plus h minus f of x is square root of x. Now, in this situation, we can't just distribute out the numerator and then combine like terms and then hope that we get like something that cancels out the h. Instead, what do we need to do here to clean this up? rationalize. We're going to use the conjugate of the numerator to rationalize the numerator. What's our conjugate going to look like? All right, root x plus h plus root x. When we distribute this out in the numerator, what do we get? X plus h minus x. So root x plus h times root x plus h is x plus h. Negative root x times positive root x is negative x. In the denominator, do not distribute out the h, just have h times the conjugate. So h times root x plus h plus root x. And now, in the numerator, what can we do? Now I can combine like terms and cancel out the x's. So you're left with h over h times the conjugate. And now how can you reduce the fraction? Cancel out the h's. And you're left with 1 over root x plus h plus root x. And you can finally now take your limit and have h run to 0. And if you take h and let it be 0, what do you have in the denominator? Yeah, root x plus root x, because x plus 0 is just x inside that first radical. And root x plus root x is 2 root x. So that's where we're getting here. So we're getting to 1 over 2 root x, because at the very end, when you take the limit and h goes to 0, now you have root x plus another 2 root x, and root x plus another root x, and anything plus itself is 2 of that thing, like casa plus casa is 2 casa, all right? Or marker plus marker is 2 marker. Root x plus root x is 2 root x. That's all that is. So that's how you get to there. Any comments to follow up on that, or any questions about any of the particular details along the way? Now, once you've got that, you can use it to then get the slope of the tangent line. So instead of going through the whole c plus h thing for 1 comma 1, and then going through the whole limit again with c being 4 for 4 comma 2, and then going through the whole limit again for when c is 0 for the point 0, 0, we go through the whole limit process one time with just generic x, and then once we've got this equation for the derivative, we use it to find the slope at different points along the way. And so that's a more efficient way to find the derivative if you have to find the derivative at various points. So this is going to be what we do a lot more often. So if we want the slope of the tangent line at 1 comma 1, we just say, all right, that slope is going to equal f prime of 1. And then you plug 1 into the derivative, 1 over 2 root 1, and what do we get? 1/2. And that's it. And if you wanted to write the equation of that tangent line, you could do that with your point and your slope and just write the equation in point slope form. Or if we wanted the slope of the line tangent to the curve at 4 comma 2, now what do we plug into the derivative? 4. So we're going to do f prime of 4. So we have 1 over 2 root x. So write down the derivative equation here, 1 over 2 root x. So 1 over 2 root 4. And what's that going to be? 1/4. And then again, you have the equation for that tangent line if you wanted to write it, because you have a slope and a point now. Now, for this third point, 0 comma 0, it's all right, slope equals f prime of 0. What happens when we plug in 0 to our derivative function? And so what does that mean about our slope? So the slope isn't vertical. The slope is undefined. And what kind of line has an undefined slope? A vertical line. So we have a tangent line that's vertical there. So anytime you have a slope that turns out it's undefined, that tells you, oh, the tangent line to the point, to the curve at that point is a vertical tangent line. And if you have a slope that's 0, what does that tell you about your tangent line? It's horizontal. So undefined slope is a semi-big deal because undefined slope tells us, oh, the tangent line is a vertical line. And if we wanted to write the equation of that line, it would just be x equals the x coordinate. So if we wanted the equation of the tangent line, x equals the x coordinate, of the point of tangency. The point is 0, 0, so it's x equals 0. So if you ever see undefined slope from your derivative, that's the tangent line is 0. Any follow-up questions with anything from example 4b? All right. Do example 5 real quick, and then 34, get f prime of x, and then we'll talk about what you do from there. So example 5 and then number 34, both of these right now, just keep practicing finding that derivative. Do you guys want to know why am I doing this to you? Why do we have to do this stupid limit process again and again and again? It's a fair question if you have. Because I want to really hammer in that formula for the limit, and you need the practice with the algebra. Start off with maybe it was at most you'll have a quiz on 2.1, 2.2. I'll let you guys know when I do that. Okay. So 5. So 5 minutes. And so T plus 8. So we need to know the ones. Well, that's not now. That's not line. That's got it. That's right. Minus F2. All of it. First half whenever you take function, whenever you see a T, that's replaced with T plus 8. Second half is the function as you see. Alright. So you're gonna have fraction from the fraction. The function itself is a fraction. So up the first half you're going to have a T plus 8. And then subtracting up to 2. It's all over. Now we want to multiply by the name of 1. So you got to multiply out and kill off these little constants. So that's what we multiply by. Out the whole fraction on bottom. All right, so setting this up, know your limit formula for the derivative. And then f of t plus h is 2 over t plus h. You take the function, and wherever you see a t, it turns into t plus h. Boom. And then you subtract f of t. So you subtract the original function as you see it. It's all over h. There's your setup. You got to be able to set this up. Once you've got that, now you're killing this whole like fractions within fractions business. So we need to kill off these two little denominators. We use them to multiply to the top and the bottom of the whole fraction. So we multiply it by t plus h and t on top and bottom. So we're really just multiplying by 1. And when you distribute this whole thing through the numerator, the t plus h cancels the t plus h in the first fraction, and you're left with 2 times t. And when you distribute to the second fraction, the t cancels out the t, and you're left with t plus h times negative 2. And just be careful that you distribute the negative as well as the 2 through the t plus h. All right? On the denominator, you'll have an h and a t plus h and a t. Now the heavy lifting is done. At this point, it's combine like terms in the numerator, divide out the h, and take your limit. So combine like terms in the numerator, the 2 t's cancel out. Divide out the h, and you're left with negative 2 over t plus h quantity t. And now take your limit. Now you can have h go to 0, and you're left with t plus 0 times t. That's just t squared underneath your negative 2. So that's f prime of t when you're all done. Any comments on that? All right, for this next one, what do y'all get for f prime of x? 4x. And before we just jump to that, at least let's see the setup. F prime of x equals the limit at h goes to 0. What does the fraction look like when you set this?
Could you move the board?
Yeah, I can do that. Sorry, Prince. So what's the fraction going to look like in your limit? So 2 quantity x plus h squared. Take your function, turn the x into an x plus h. That's the only x, so lucky us. And then what? And then all over h. So that's your setup. So not 2x squared plus h. 2, the x itself turns into x plus h. That whole thing gets squared. And then you're subtracting the function. And when you go through that whole process, you get f prime equals 4x. Now, the rest of this is now a little bit tricky. So we want to find out the equation of the tangent line, not to any particular point that we're giving you. So instead of saying, find the equation of the tangent line that goes through, I don't know, 2, 8. And then you say, oh, I have a point for x, I have a value for y, I have my slope, good. Here, you got to be a little clever and say we want to be parallel to this line. So in order to write the equation of a tangent line, or any line, you need to remember 2 basic needs. So line equation needs. Write this down. The line equation needs. What are your 2 basic needs for writing the equation of a line? The slope and y-intercept is a specific version, but it doesn't have to be the y-intercept. It could be any point on the line. Now, for us, the slope is going to be coming from the derivative, because derivatives are slopes. So the slope is going to come from f prime of x. The point is going to be the point of tangency. What's tough about this problem is that they're not giving you anything with regards to the point. Normally we give you the point of tangency, or at the very least we give you the x-coordinate that you can use to find the y-coordinate, and then you have the point of tangency. Here they're giving you nothing. They're just giving you some other line and saying, we want our tangent line to be parallel to this guy. So what we need to do is take this guy and find the slope. So 4x plus y plus 3 equals 0. If we need to be parallel to this line, then we need to know this line's slope. How do we find the slope of this line? Get y by itself. If we get y by itself, what's the equation of the line? And what's the slope of this line? Slope is negative 4. So the slope is negative 4. And so our tangent line is going to have what slope? -4. So ding, ding, ding. That's going to be the slope of our tangent line because we want to be parallel, and parallel lines have the same slope. So now we've got our slope. We still don't know anything about the point, but we do know that slopes are the same thing as derivatives. So what can we do with our slope and our derivative? Set them equal, and then we can use that to work on finding the point. So once we've got our slope of the tangent line, we can say, you know what, I know that derivatives and slopes are the same thing. So derivative equals slope. Set those equal to each other. We know the slope of our tangent line has to be -4, and we know our derivative is 4x. Solve for x. What's x equal? -1. So now we know our tangent line to this curve has a slope of -4 when x equals -1. All I have left to do is find the y-coordinate. And just as m equals f prime of x, and we can't emphasize that enough, y equals f of x. So once you got that, find out y using this relationship that y equals f of x. F of x is just fancy y, like a derivative is a fancy slope. And so if we do f of -1, that's just 2 times -1 squared, and that's what? 2. So now you have your point of tangency. You got your slope. It turns out from the line that we want to be parallel to, those parallel lines have the same slope. So take the line they gave you, find the slope. Now you got the slope of your line. And then remember that derivatives and slopes are the same. So take your derivative, take your slope, set them equal, solve for x, use that x to get the y, and then you know your point of tangency is 1, 2, -1, 2. And now you can take those two things together and write the equation of your line. So here's your tangent line, the equation over here. So, and again, I'm just going to use point slope form because I think it's the most easy thing to do. So y minus what? 2 equals -4, the slope, times the quantity, x plus 1. That one's a somewhat heavier problem because, again, they're not really helping you out at all, especially with regards to the point of tangency. You got to come up with that on your own. And this is where this relationship, slope and derivative, is a big deal. And then this other relationship, y equals f of x, is a big deal. We're going to come back. These two relationships can get you pretty far in differential calculus. If you can keep straight, slope equals derivative and y equals f of x, those two things together get you a long way. Any questions with that? So I think on your homework, 31 and 33, the last two problems from 2.1b are more practice like that. That's a good kind of question. So you'll see those again. Yes, Prince.
So after you find x equals -1, where did you plug it into to get y equals 2?
So once you got x equals -1, you're plugging it into the function 2x squared. So that's what this here is saying. Y equals f of x. So once you have an x coordinate, if you want a y coordinate, plug the x into the function and find out y. So remember, f of x was 2x squared. So you have 2 times -1 squared to get your y value. Raisa?
Thank you.
Why didn't I take -1 and plug it into the derivative? Because that would tell me the slope of the tangent line. The derivatives are slopes. But remember, we already know the slope of the line because we want to be parallel to this guy, and that's how we found the slope. So once we knew the slope from the parallel line, we set that equal to the derivative and used that to find our x. Once we've got our x, we've got our slope, we've got our x, we've got to find our y. This is another reason why labeling stuff is so important. If you don't label things like, oh, that's my m, oh, this is my x, then you don't know what piece is what, and how it all fits together. So it's super important for us that we label stuff as well. Anything else? Nope, wrong thing. Over here. All right, 64, not on the homework, but a good problem for us to think about and discuss. First of all, look at the graph. What is this a graph of? G prime of x. So it is a parabola, but it's a graph of what function? G prime. So this is a derivative. So instead of showing you, hey, here's a curve G, I'm telling you, here's the derivative of G. This is what the derivative looks like. And remember, what are derivatives the same as? Slope. So this curve tells us the slope of what? G. So G prime is the slope of G. G prime means the derivative. Derivatives are slopes. It's the slope of the G function. So when we say G prime of 0, this is the graph of G prime. You just go to x equals 0 on this graph, and the output from this graph is G prime of 0. So what's G prime of 0? -3. That tells us that the slope of G is -3 when x is 0. What's G prime of 3? 0. So that tells us that the slope of G is 0 when x equals 3. You can even write that down here. Slope of G is 0 for when x equals 3. That's what that means. So what does G look like right at when x equals 3 if the slope is 0? What do we say it? Not all lines are straight. Horizontal. It's a horizontal curve. So G is a curve, and at 0, in what direction is he going? Up or down or flat? Down, because the slope is negative. At x equals 3, up, down, or flat? He's flat. I'm telling you in C, G prime of 1 equals -8/3. So that tells us that G is going in what direction? Down, because the slope is negative. So you can say, hey, the derivative is negative, so the slope is negative, because derivatives are slopes. And so we can say that G is going down at x equals -1. And that's pretty much all you know about it from that one piece of information. Similarly, G prime of 4 being 7/3 tells us what about the G curve? G is going in which direction? Up. Because why? Because the slope derivative is positive. So G going up at x equals 4. Any questions about A, B, C, D? Anything we just discussed in those 47 seconds right there? E and F are considerably more difficult to think about. So 6 and 4, if we just kind of continue the curve and assume it continues like this, we got 4 and 6. What do you notice about G prime over here? Is it positive or negative? Positive, and is it getting more positive or less positive as you continue off to the right? More, right? So as you go farther off to the right, your derivative gets bigger and bigger and bigger positive. So on the original function, if we keep just going up, up, up with a derivative, then what's G doing if our slope is getting more and more? If I had to try to draw a G, this is hard to think about. If you had to try to draw your G curve, and we know that the G prime is positive, what is the G curve doing? It's going up. And is it going up faster and slower as you continue on to the right? It's going up faster and faster and faster because our derivative keeps on getting more and more and more positive. So what point is going to be higher on the G curve? At 6 or at 4? So when you subtract them, are we positive or negative? Positive, right? Any questions with that? Ryan? Eventually. But these are not the points on the G curve. These are the points on G prime. So this is just telling you the slope. So you know the slope of G here, you know the slope of G here, and here, and here. But you don't know any points on the actual G curve. Yeah, it's right there. Oh, can you tell the equation of the G curve? Yeah, you could probably figure that out and then kind of work backwards to the equation of the actual function. That's a lot of work, though. This is harder to think about, maybe, but it's quicker to just do this way. Now, if we don't know, do we know any points on the G curve? Because all the points we know are on what curve? G prime. So the only points we know are on G prime, so we just know a bunch of slopes, but we don't know any points on the actual G curve. So can we find out G of 2? No. We would have to give you like a starting point on the G curve, and then maybe you could figure out G of 2 from there using slopes. But if you don't know any starting point on the G curve and all you know is the derivative, then you can't find any particular point on the G curve without a starting point to work from. So this is kind of laying the groundwork for what's called differential equations, which comes much later. That's like chapter 6 stuff. But this is kind of starting to make you think about the relationship graphically between G prime and G. Something that we're going to have you guys do next week is I'm going to give you a graph, and I'm going to say, this is what G looks like. What do you think G prime looks like? Just draw me a rough sketch. And trying to think about the graphical representation between a curve and its derivative. And then kind of going back and forth. Laura, I saw a hand up. So here we're trying to ask you to think about, you don't know what either of these points is, so I meant it like this. Yep. So that's a good question. So why are we thinking about this? So this is kind of telling you the difference in the height of the curve from 6 back to 4. And if you know that G prime is positive over here and getting more positive, then you know that the G curve is increasing. So you know it's gone up from 4 to 6. So then you know that when you subtract them, G of 6 minus G of 4 is going to be positive because G of 6 has to be higher because the G curve is going up since G prime is positive over there. All right. So that one, out of all of these, I think that's one's the toughest one to kind of wrap our head around right now. So the weekend homework 2.1b is more practice of what we've been doing mostly the last couple days. You have a couple questions like that with the tangent line that's parallel to some other line. And then next week, we're going to continue to look at this, but try to get at a more conceptual level instead of just the nitty-gritty details of taking a limit a million times. And you do have one delta math that needs to be done by Monday, so make sure that's done. And then all the delta maths for next week are up and available if you want to work ahead. I think we're done. So Joanna, can you come by during Flex today? Okay. Do I need to email your teacher, or is that cool? Okay. Yeah. Nope, you don't want that one.
Also, thank you for the recommendation.
I didn't. I'll be honest. I didn't recommend you.